Okay, so today we are looking at our Unit 5 review. Our first learning target was that we can solve a system of equations graphically. So when we look at number 1, we have y equals negative x plus 2. That's already in slope-intercept form for us, which is very convenient. We see our y-intercept is at positive 2, so we can plot a point at positive 2. And our slope is negative 1, so we can go down 1, right 1 to get that negative slope. And up 1, left 1. And we can go ahead and graph that line. Y equals negative x plus 2. And then our second line is x equals negative 7. So that means that our line goes through the x-axis at negative 7. And if you struggle still with vertical and horizontal lines, I would encourage you to make a table of values. All of your x values are negative 7. Okay, so no matter what y equals, x equals negative 7. Okay, so you can, if you need to be sure, you can just plot some points. Okay, negative 10, negative 7, 0, negative 7, and I'm sorry, I did that completely wrong here. So negative 7, negative 10 is here. Negative 7, 0 is here, and 7, 10 is here. So going through the x-axis at negative 7. Okay, and then we can see that our point of intersection is at negative 7, 9. Okay, and then you can plug that into both of the equations to make sure it's true. So the first equation, y equals, will be 9 equals negative x. Well, x is negative 7, so negative x will be 7 plus 2 is 9. And then the second one is obviously true, x equals negative 7. Okay, number 2, these are not in slope-intercept form, so we need to rewrite them so that they are in slope-intercept form so we can graph them. So our first equation is 4x minus 3y equals 15. So we'll subtract 4x from each side. That gives us negative 3y equals negative 4x plus 15. And then divide each term by negative 3 to get y equals 4/3 x minus 5. So that's in slope-intercept form. Then the next equation is x plus 6y equals 24. Okay, so we'll rewrite that in slope-intercept form to get 6y. So subtract x from each side to get 6y equals negative x plus 24. Then divide each term by 6 to get y equals negative 1/6x plus 4. So those are the two lines that we need to graph. So the first line, y equals 4/3 x minus 5, we'll put our y-intercept at negative 5. And our slope is positive 4/3. So we'll go up 4, right 3, up 4, right 3. Then I'll do from this y-intercept down 4, left 3. Okay, that's our first line. And then our next equation is y equals 1/6x plus 4. So this has a y-intercept at positive 4 and a slope of negative 1/6. So we'll go down 1, right 6. That takes us right into our point of intersection. And just to make our line longer, I'll go up 1 and left 6. Helps to make our line more precise. Okay, and our point of intersection is at 1, 2, 3, 4, 5, 6, 3. So our solution here is 6, 3. And remember, we want to check these algebraically to make sure that it satisfies both equations. Then we know we have the correct solution. Okay, number 3. So hopefully we are at the point where we can look at this equation, notice that our x values are the same, our y values are the same, but our integers are different. So we should be able to look at this and predict that these are going to be parallel lines. All right. So when we rewrite these into slope-intercept form, we'll prove that, and we know that parallel lines have what? No solution. So let's prove that algebraically though, because we want to be sure. So we have x minus 5y equals negative 40. Subtract x from each side. That gives us negative 5y equals negative x minus 40. Divide each term by negative 5 to isolate y. This gives us y equals 1/5 x plus 8. Then we take our second equation, rewrite that in slope-intercept form. We have x minus 5y equals 25. Subtract x from each side. This gives us negative 5y equals negative x plus 25. Divide each term by negative 5 to get y equals 1/5 x minus 5. So then we see these two lines have the same slope, but a different y-intercept, so we know they're going to be parallel. But again, this is solved by graphing, so we do need to prove it with our graph. So our y-intercept here is positive 8. And our slope is positive 1/5. So up 1, right 5. Down 1, left 5. Okay. Okay, so that's our first line. Remember, we plot our points, we use a straight edge to graph our lines, and we extend our lines to the edges of the graph. Our next line is y equals 1/5 x minus 5. So here we have a y-intercept at negative 5. Okay, again, a slope of positive 1/5. Right, and so that we can graph that line. Okay, and we see that we have parallel lines, so there's no solution. Sorry, parallel lines, so no solution, which we already wrote at the top. Okay, moving on to number 4. Here we have, they're both in standard form. If our instructions were not solved graphically, we would probably like to use elimination, but we do need to solve with graphing because that's what this set of instructions says. So we'll rewrite each of these in slope-intercept form. So subtract 2x from each side to get 5y equals negative 2x plus 30. Sorry, I was off the screen there. So that's the first equation. We're just rewriting it in slope-intercept form. Then divide each term by 5 to get y equals negative 2/5 x plus 6. Then we'll take our second equation, rewrite that in slope-intercept form. So we have 7x minus 5y equals 15. Subtract 7x from each side. We get negative 5y equals negative 7x plus 15, and then divide each side by negative 5 to get y equals 7 fifths x minus 3. Okay, so then let's go ahead and graph these two lines and find their point of intersection. So our first line is y equals to negative 2 fifths x plus 6. So our y-intercept is 6. Oops, 1, 2, 3, 4, 5, 6. Our slope is negative 2 fifths, so down to right 5. Up to left 5. Okay, and then graph that first line. And then our second line is y equals 7 fifths x minus 3. So we have a y-intercept of negative 3 and a slope of positive 7 fifths. So we see our point of intersection there. Okay, we'll go off the chart at that point. So we see if we can go down 7. Okay, so then we can graph that line. And our solution is at 5, 4. Okay, so our solution to this system is 5, 4. And we always want to check that algebraically so that we know we have it correct after all of that work. Because we could have made a little mistake somewhere in either one of those equations, or made a mistake with graphing like a positive slope instead of a negative, or vice versa. So always check those algebraically x, y into both equations and make sure that it's true. All right, on to substitution review. All right, so the next page we're looking at solving systems of equations using substitution. Number 1 or number 5, when I look at these, they're both set up to y, to equal y. So instead of, if they're both equal to y, they're both equal to each other. So we can use simple substitution to solve this very conveniently. Okay, so if y is equal to 2x plus 7 and y is equal to 4x plus 19, so if this is equal to y and if this is equal to y, then this is equal to that. They're equal to each other. Okay, remember that from the very beginning of the unit. If they're both equal to y, they're both equal to each other. So we can write this equation. 2x plus 7 is equal to 4x plus 19. Okay, and then I'm going to go ahead and subtract 2x from each side to get our x's on the same side. This gives us 7, because that cross cancels, 7 equals 2x plus 19. Then we'll subtract 19 from each side to get negative 12 is equal to 2x. Then divide each side by 2 to get x equals negative 6. So we know the x value is negative 6, and then we can plug that into either one of the y values, or excuse me, into either one of the equations for x to solve for the y value. I'll plug it into the top one. So y is equal to, instead of 2x plus 7, I say 2 times negative 6 plus 7. So y equals negative 12 plus 7. Y equals negative 5. And we would check that algebraically, plug it into both equations, make sure when x is negative 6, y is negative 5. Okay, let's go ahead and do that just very quickly. Negative 6, so 2 times negative 6 is negative 12. Negative 12 plus 5, or excuse me, negative 12 plus 7 is negative 5, so that checks out. The second equation, 4 times x, so 4 times negative 6 is negative 24. Negative 24 plus 19 is negative 5. So just a quick check step. You don't even need to write it down. You can do that in your head. If it's helpful to write it down because you're not really super proficient with integers or you just want to see it, then write it down. Number 6. So with substitution here, I have y equals 4x minus 2 and 8x minus 2y equals negative 3. So I see that the y is already isolated by itself, so that's what I'm going to use to sub in. So when we have, just gonna pause for a moment. All right, so the y is already isolated, so that's what I'm going to substitute in. So I'm going to rewrite this equation, but instead of the y, I'm going to substitute in 4x minus 2. So 8x minus 2 times the quantity 4x minus 2. Okay, and then equals negative 3. Okay, so I just took this y value and I subbed it in right here, okay, into this y. Then I'll go ahead and distribute that negative 2, 8x minus 8x plus 4 equals negative 3. 8x minus 8x is 0. 0 plus 4 equals negative 3. 4 equals negative 3. Well, that's never true. And if it's never true, that means we have no solution. So these are parallel lines that will never intersect. And if you aren't sure about that, what can you do? You can rewrite them so they are in slope-intercept form, compare their slopes. Their slopes will be the same. Their y-intercepts will be different because they're parallel lines. Okay, number 7. So the easiest variable to solve for will be this top x because it already has a coefficient of 1. So this has a coefficient of 4, this has a coefficient of negative 2, this has a coefficient of 3, so that x will probably be the easiest variable to isolate. So I'm just going to work right over here in this small space to the left. We have x plus 4y equals 9. We subtract 4y from each side. This gives us x equals negative 4y plus 9. So now we have that x variable. If I rewrote the first equation to solve for a variable, then I need to sub that into the other equation. So I'm substituting it into the second equation. So I'm rewriting this equation. Okay, negative 2, but instead of times x, I say negative 4y plus 9, and then bring down the plus 3y equals negative 7. Okay, then I'm going to distribute the negative 2. Okay, so I get negative 2 times negative 4y is 8y. Negative 2 times positive 9 is minus 18. Bring down the plus 3y equals negative 7. Then we can combine like terms. 8y plus 3y gives us 11y minus 18, and then bring down the equals negative 7. We'll add 18 to each side. This cross cancels. 18 minus 7 is the same as negative 7 plus 18. So that's 11 equals, and then bring down the 11y. Divide each side by 11 to get y equals 1. So we now know the y value is equal to 1. I can sub that in and solve for x. So since I already have the x isolated here, I'm going to substitute into this one, okay? So x equals negative 4 times 1 plus 9. X equals negative 4 plus 9. Negative 4 plus 9 is the same as 9 minus 4. So x equals 5. So our solution is 5, 1. And then again, we always want to plug those in algebraically. You'll have plenty of time on your test to check your answers. So take the time to do that. Plug it into the first equation, make sure it gives you a true statement. Plug it into the second equation and make sure it gives you a true statement. Okay, number 8, we have 3 variables, we have 3 equations. So we see the first or the last equation is given that z is equal to 1. So I'm going to go ahead and plug this z and substitute it into the second equation. So here's my second equation rewritten. Y plus 3 times, but instead of z, I'm subbing in 1 equals 5. So y equals 3. Oops, I'm sorry. Y plus 3 equals 5. Subtract 3 from each side to get y equals 2. So I know, I don't know x yet. I do know y is 2. And we were given that z is 1. And remember, this is an ordered triple. It's x, then y, then z. It's always alphabetical. It's an ordered triple, x, y, z. So we know z is 1. We know y is 2. We can substitute those in and solve for x using the first equation. So here's my first equation. X plus 2y minus z equals 6. X plus 2 times 2 minus 1 equals 6. X plus 4 minus 1 equals 6. X plus 3 equals 6. Subtract 3 from each side to get x equals 3. So 3, 2, 1 is our ordered pair. All right, our next standard is solving systems of equation using elimination. So let's review elimination. All right, so when I look at elimination, number 9, it's really nicely set up for me already. So I see they're both in standard form and the y's are already set up to cancel out. So I can just add the two equations together because these y's will automatically eliminate. Negative 8x plus 5x is negative 3x. The y's cross cancel, bring down the equal sign. Negative 8 plus 5 is negative 3. Divide each side by negative 3. And we get x equals 1. Then once I know x equals 1, I can substitute that into either one of the original equations and solve for y. So I'll just take this second equation, 5, instead of x, I say 5 times 1 plus 4y equals 5. 5 plus 4y equals 5. Subtract 5 from each side to get 4y equals 0. Divide each side by 4 to get y equals 0. And then again, we would always do our check step. Number 10. The least common multiple of 2 and 4 is 4. Least common multiple of 7 and 1 is 7. So 4 is smaller than 7, so I think I will eliminate the x's because the least common multiple is 4. So the top equation already has a positive 4, so for the coefficient of x. So I want to make the bottom equation have a coefficient of negative 4, okay? So I need to multiply by negative 2. This one I'm going to bring straight over. 4x minus 7y equals negative 14. The bottom equation, I need to distribute that negative 2. This gives me negative 4x plus 2y equals negative 16. Okay, then I can combine the equations. 4x minus 4x cancels out. Negative 7y plus 2y is negative 5y. And negative 16 minus 14, or negative 14 minus 16 is negative 30. Divide each side by negative 5 to get y equals positive 6. And then once I know y is positive 6, I can substitute that into either one of the other equations. It doesn't matter, and then solve for x. So I'll just plug it into this one because it's the numbers are slightly smaller. It does not matter at all, though. 2x. This is minus y, so we'll say minus 6 equals 8 equals 8. Add 6 to each side to get 2x. This cross cancels. Excuse me, cancels out. To get 2x equals 14. Divide by 2, and we get x equals 7. Okay, and again, we would check that algebraically to make sure that we have the correct answer, and we would check it in both equations. Yeah. All right, let's take a look at number 11. We have 12x plus 12y equals 20, negative 8x minus 8y equals negative 8. We can have a least common multiple of 24 for 8 and 12, so it doesn't matter which ones we cancel out. So first of all, let's notice they're both in standard form. Okay, so they're ready to go as far as finding a term to cancel out. So to have the x's cancel out, I'll multiply by 2 in that top equation to get a positive 24x, and I'll multiply by 3 in the bottom equation to get a negative 24x, and then distribute. I don't want to try to squeeze this in here, so I'll write it underneath. So here's the first equation. 2 times 12x is 24x. 2 times 12y is 24y. And then 2 times 20 is 40. Then we'll do our 3. So here's our second equation. 3 times negative 8x is negative 24x. 3 times negative 8y is, oh, I forgot the 4 here. Let me fix that. Sorry about that. So, but to the second equation, we're multiplying by 3. 3 times negative 8x is negative 24x. 3 times negative 8y is minus 24y. 3 times negative 8 is negative 24. So then when we add these together, what's going to happen is our x's cancel out. 24x minus 24x is 0. Our y's cancel out. 24x minus 24x is 0. So we end up with 0 equals, okay, we have 40 minus 24. 40 minus 20 is 20. Minus 4 is 16. So we end up with 0 equals 16, which is never true. So we have no solution. Okay, those would be parallel lines, and they would never intersect. All right, and then let's take a look at number 12. We have 10x minus 8x equals negative 20. Negative 9x plus 3y equals 18. So we can have the y's cancel out. Our least common multiple would be 24. So let's cancel out our y values. This is already negative, that's already positive. So let's take our top equation and multiply by 3. Take our bottom equation and multiply by 8. And we do have plenty of room here, so I'm just going to move this right over to the right. 3 times 10 is 30x. 3 times minus 8y is negative 24y, or minus 24y equals, and 3 times negative 20 is negative 60. See if we can get that to focus a little bit better. There we go. And then we'll distribute the 8 here. 8 times negative 9 is negative 72x. 8 times 3y is 24y. 8 times 18, 144. okay? And so then our y's are going to cancel out here. That's great. So negative 72x plus 30x is going to give us negative 42x. Negative 24y plus 24y, that cancels out. 144 minus 60, that's going to give us 84. So positive 84. Divide each side by negative 42. This gives us x equals negative 2. We can plug that into either one of the original equations. I'll choose that bottom one. So 9x, negative 9, excuse me, times x will be negative 9 times negative 2 plus 3y equals 18. Negative 9 times negative 2 is 18. Bring down the plus 3y equals 18. Subtract 18 from each side. This gives us 3y equals 0. Divide each side by 3 to get y equals 0. So our solution is negative 2, 0. And we would plug that into each of the original equations to check for accuracy. Okay, so that is a review of solving systems of equation using elimination. Okay, 13, 14, 15, and 16. Solve a system of equations by using any algebraic method. So you can decide which method you want to choose and then solve. So number 13, these are both already set up in standard form. The y's are positive y and negative y already, so the most efficient way to solve would be with elimination. We see the y's will cancel right out. So we add these together. Negative 2x plus x is negative x. Negative y plus, let me focus that a little bit. Negative y plus y, those will cancel out. And then bring down the equals. Negative 10 minus 1 is negative 11. Then we divide each side by negative 1 to get x equals 11. All right, and then once we know that x is equal to 11, we can substitute that into either one of the original equations to solve for y. So I'll choose the second equation. Sub in the 11. Subtract 11 from each side to get y equals negative 12. And again, we would check that algebraically. Okay, number 14. I see the x value, the x variable is already isolated, so I would probably use substitution for this one because the x is already solved for. And then I would plug it in here. So I'll rewrite that second equation. But instead of 2 times x, we'll say 2 times the quantity 3y minus 13. Bring down the minus 7y equals negative 30. And then we distribute the 2. Get 6y minus 26 minus 7y equals negative 30. Okay, combine like terms, 6y minus 7y is negative y. Bring down the minus 26 to the negative 26. Bring down the equals negative 30. Add 26 to each side to get negative y equals negative 4. If a negative y is a negative 4, you can divide each side by 1 to find that y is equal to positive 4. So if a negative y is a negative 4, then a positive y is a positive 4. And then once we know what y is, we can substitute it into either one of the original equations to solve for x. I'll choose the second equation since that x is isolated. So x is equal to 3 times y. So I'll substitute in 4 here, minus 13. X is equal to 12 minus 13. So x is equal to negative 1. So our solution is negative 1, 4, and you would check that algebraically. Okay, so 15, we have to determine the strategy that we'd want to use. We see this; these are both already in standard form, so that's really conducive to solving with elimination. Then we look at it and say, well, which term would I like to solve to eliminate? The least common multiple of 5 and 3 is 15. That's not a huge number, that's fine. But the least common multiple of 2 and 8 is 8, so that's a little smaller, so I would like to choose the y's. Can I cancel out the x's? Absolutely. It will still work just fine. This is already a negative 8y, so I want to make this a positive 8y, which means I'm multiplying my entire bottom equation by 4. The top equation, we're just bringing straight over, 3x minus 8y equals negative 19. The bottom equation, we're multiplying by 4, so we get 20x plus 8y equals negative 4. Then we add the two equations together. We get 23x. Negative 8y plus 8y is 0. Bring down the equals. Negative 19 minus 4 is negative 23. Divide each side by positive 23 to isolate the x. This gives us x equals negative 1. And then I can substitute that into either one of the original equations to solve for y. So I'll use the second equation. So 5 times negative 1 plus 2y equals negative 1. So negative 5 plus 2y equals negative 1. Add 5 to each side to get 2y equals 4. Divide each side by 2 to get y equals 2. So we get negative 1, 2 as our solution. Okay, and then you plug those in algebraically to check for accuracy. Okay, so here is a little bit of it. Let's use a little bit of a different twist. We haven't done one quite this way before. When I'm looking at number 16, I see 3x equals y plus 7, and then in that top equation I see a 3x. We haven't done one this way before, but this is, we can, as long as we're following the golden rule of algebra, we can substitute however we want to. The golden rules of algebra, we can substitute however we want. This tells us that 3x is equal to y plus 7. So I can go ahead if I want to, and instead of writing 3x, what can I write instead? I can write y plus 7, because I know that 3x is equal to y plus 7. So I can take this and I can substitute it right in here. And that gives me a one variable equation. Okay, so instead of 3x, I'm going to say y plus 7. And then bring over the minus 3y equals negative 3. If that's too confusing for you, you don't have to do it this way. You can solve with elimination, you can solve with substitution, whatever you like, okay? But this is just, it is still substitution, it's just a little bit more complex because we're not just subbing x or y, we substituted 3x because this equation told us 3x is equal to y plus 7. Okay, so now I'll combine like terms. Y minus 3y gives us negative 2y, bring down the plus 7, equals negative 3. Subtract 7. From each side, this gives us negative 2y equals negative 10. Divide each side by negative 2 to get y equals 5. Okay, so we know the y value is 5. I can substitute that into either one of the original equations and solve for x. I'll use the bottom equation. So here's the bottom equation. 3x equals, instead of y plus 7, I'm writing 5 plus 7. So 3x equals, combine like terms, 12. Divide each side by 3 to get x equals 4. So our solution is 4, 5. And then algebraically plug that back into both original equations and check to make sure it makes both equations true. Okay, next standard, I can find a solution would give it a graph, either exact or approximation. Okay, so remember, if you have two functions, your solution has to go through both of those in order to be correct. All of these only have two, so it's pretty straightforward. But what I'm saying is if you had a third function, it would have to be an intersection of all three of the functions. So let's take a look at 17. This is the first equation, let's see, or the first point of intersection. We are going to need to approximate. So approximately negative 2.1. And it's not quite 1, let's say 8/10, so 0.8. Okay, and then our second solution is right here, almost 3, so let's approximate that to 2.8. And a little more than 3.5, so 3.7. Okay, so we have two solutions there. This shape is called a parabola. Okay, so the line intersects the parabola at 2 points. Okay, number 18, we have two parabolas, and these functions will just intersect each other once, and that's right at negative 2, 1. So negative 2, 1 is our point of intersection. All right, number 19, we have two parabolas. One opens upward, one opens downward. So let's see where they intersect. This is negative 4, 3. Negative 2, negative 1. Okay, so two solutions for number 19. Okay, and then when we look at number 20, we have two parabolas, but the more narrow parabola has a vertex that's higher than the wider parabola, so they'll actually never intersect. So if they're never going to intersect, so this goes up forever, but it's wider. This one goes up forever and it's more narrow. So they're not going to intersect ever. So no solution. Okay, so that is finding a solution when given the graph. Okay, the next section of review is actually from today's notes. Okay, so we're choosing a method that's most appropriate to solve and just explaining why we would choose that method. If you have both equations in slope-intercept form, you have a couple choices. You can do a simple substitution where they're both equal to y, they're both equal to each other. So we would use substitution for this and say 2x minus 7 equals x plus 4. Again, we do not need to solve these, we just need to say how we would solve them and then give our explanation. So for this 21, we would use substitution. Okay, so this is, both equations are solved for y, so we can set the right side of each equation equal to the right side of the other equation. So both equations have the y isolated. So we can set the right-hand side of each equation equal to the other, or the right-hand sides equal to each other. So we can set the right side of each equation equal to the other right side to solve for x. Okay, so it's easy to substitute that, simple substitution. Okay, number 22. These are both in standard form. Okay, the x's line up, the y's line up, the integers line up. So this is elimination will be a really easy method to use. Okay, they're already in standard form, so that is easy to cancel out an x or a y. So both equations are already in standard form. Making it easy to cancel out a variable. Okay, 23 is also elimination for the same reason. And 23 is even easier. The 4y and the negative 4y already have opposite integers. Okay, so 23 is also elimination. Okay, the y terms are already set up to cancel out. The y terms are already set to eliminate. Okay, 24, what would be an efficient method here? I see the x is already isolated, and so that would be an easy system to use substitution to solve because the x term is already isolated. Okay, so the x variable in the bottom equation is already isolated. Making it easy to substitute. Sorry, it went off the screen. They're making it easy to substitute. Okay, and 25, I would say graphing. You could also do it with substitution because they're both equal to y, but you would have a fraction that's, and I know you can handle that. But these are pretty nicely set up to graph. They have easy y-intercepts, so you can do graphing or substituting here. Just explain your rationale. So I'll say graphing. Both equations are in slope-intercept form. And have points that are graphable. Like we don't have a y-intercept of like negative 2.675 or anything like that. So both equations are in slope-intercept form and are easily graphed. So meaning they have friendly numbers for graphing. Okay, and then our last section of review is modeling. At a bake sale, many cookies are sold at $1 each, and a few cakes are sold at $6 each. The difference in the number of these items sold was 17. Okay, so we know there were many cookies, so there were more cookies sold than cakes, because it says a few cakes. And the difference sold was 17, okay? So we have cookies and cakes. Both of those start with C. So let's do cookies. We'll make that one C. And cakes, we'll make that one K. Okay, so it had many cookies sold and a few cakes. And the difference sold was 17. So this first equation is going to be about the number of items sold. Okay. And then they also told us the total sales for cookies and cakes together was $52. So for this one, the second equation, and it doesn't matter which one you do first or second, is going to be about the amount of money in sales. Okay, so the difference in the number of items sold was 17. We know that there were many cookies and a few cakes. So it's going to be cookies minus cakes equals 17. That's our first equation. And the next equation is about items or money in sales. So cookies were $1 each. So $1 per cookie, plus cakes were sold at $6 each. So $6 per cake. And you can write the coefficient of $1 per cookie if you want to, but I just didn't. And then the total sales were $52. So this will equal $52. And so then if I want to cancel these out, they're already both in standard form. I would probably want to use elimination. So I'll take my top equation and multiply the entire top equation by -1. The bottom equation, I'll just bring that straight over. So -1 times C is -C, -1 times K, or excuse me, -1 times -K is a plus K, and a positive 17 times a -1 is a negative 17. This one, I'll just bring it right over. Okay, so C plus 6K equals 52. Then we have, so 52 minus 17 is going to be 35. K plus 6K is 7K. And the C minus C, or -C plus C, these cancel out. So we have 7K equals 35. Divide each side by 7. We get K equals 5. So we know we sold 5 cakes. And then I can plug that into either one of these equations to solve for the number of cookies. So this was cookies minus cakes, which is 5, equals 17. Add 5 to each side to get cookies equals 22. So 22 cookies were sold and 5 cakes were sold. (17) A rectangle has a perimeter of 20 feet. Okay, so I'm just going to draw a rectangle because I always like to have a drawing to refer to. And its perimeter, let's see, the rectangle has a perimeter of 20 feet. So I'll say 2, so L is for length. W is for width. So perimeter is our first equation. 2 lengths plus 2 widths equals 20 because they tell us the perimeter is 20. So 2L plus 2W equals 20. Okay, and then they also tell us 4 times the length is equal to 2 less than 8 times the width. Okay, so 4 times the length, so 4L is equal to, equals 2 less than what? 2 less than 8 times the width. So I have to start off with 8 times the width and then take away 2. So that was this equation. I'm going to read that again, okay? 4 times the length, 4L, is equal to, equals 2 less than 8W. 8W minus 2. Okay, write and solve a system to find the length and the width of the rectangle. Okay, so we have our two equations. Now we just need to, we can either solve with substitution or we can solve with elimination. I'm going to use a different strategy here. I have 2L. I have right here, I want to substitute in here. I'm just going to solve for 2L because when I look at this bottom equation, I see these are, you can use regular L, just so you know, but I'm going to use a different strategy right now. I'm just going to make it, it's just one step more complicated thinking, but it actually saves a step in writing. So you can use our traditional substitution where you isolate for L, solve for L, distribute by multiplying by 2, and then simplify. But what I'm going to do is I'm going to take that bottom equation, and I want to sub in 2L here. So I'm going to take this bottom equation and basically multiply it by half or divide by 2, okay? So if I multiply by half or divide by 2, I end up with what's half of 4L? 2L equals what's half of 8W? 4W. What's half of minus 2? Minus 1. So I took this equation and I just divided it by 2, okay? These three values had a GCF of 2, so I divided it out. And now I have 2L equals 4W minus 1. So in this equation, I have a 2L. I can substitute that in, okay? And again, if this is just kind of one step higher than what we've done with a substitution before, if it's too confusing, go back to the more basic substitution. So here, instead of saying 2L, I'm going to say 4W minus 1. That's where the 2L was. So now instead of 2L, all I did was say 4W minus 1. Then I'm going to copy the rest of the equation as it's written. Plus 2W equals 20. Then combine like terms. 4W plus 2W is 6W. Bring down the minus 1. Bring down the equals 20. Okay. Add 1 to each side. I get 6W equals 21. Divide each side by 6. And we get W equals 3.5, I think. Let's see here. 3.5. Yep. Okay, so W is 3.5. Okay, and then I can substitute that into any of the equations and solve for L. So I'll sub it in here. W is 3.5. So I'm just taking this one and rewriting it here. 2L is equal to 4 times W, so 4 times 3.5 minus 1. So 2L is equal to 14 minus 1. 2L is equal to 13. Divide each side by 2 to get L equals 6.5. Okay. So our length is 6.5. And these were both in feet. Okay, so the length equals 6.5 feet, and the width is 3.5 feet. Okay, 28. Mrs. Smith sold 147 used books at the book fair, paperbacks. Okay, so we'll call P the number of paperbacks. We're $4 each, and hardcover books, we'll call H the number of hardcover books. We're $7 each. Her sales totaled $735. Write and solve a system of equations to determine the number of paperback and number of hardback books sold. So first of all, we're going to write one equation about the number of books sold. And the second equation is going to be about the sales amount. and that's in dollars. Okay, so we know that she sold 147 books. So we'll say the number of, our first equation is about the number of books. Paperbacks plus hardcovers equals 147. Okay, our next equation is about sales. Paperbacks were $4 each, so $4 per paperback plus $7 per hardcover equals $735. Okay, so that was our total amount in sales. So we can decide how we want to solve these two equations. They're both in standard form. I'm going to go ahead and use elimination. The bottom, I'm going to cancel out the p's. The bottom equation has already a 4p, so I'm going to take my top equation and multiply it by -4. So -4 times p is -4p. I'm just going to white this number out so it doesn't confuse anything or get in the way. -4 times p minus -4 times h, so -4h equals, and we have 147 times the -4, that's going to give us -588. The second equation, we're just bringing that straight over. 4p plus 7h equals 735. The p's will cancel out. -4h plus 7h is 3h. And 735 minus 588 is 147. Divide each side by 3 to get the number of hardcover books. 147 divided by 3 is 49. So 49 hardcovers. And then we had that original equation. Paperbacks, we'll substitute that into the original equation. Paperbacks plus hardcovers at 49 equals 147. Subtract 49 to get 98. So 98 paperbacks and 49 hardcovers were sold. So Ms. Smith, I'm so out of room here, but I'm just going to squeeze it in the corner. Ms. Smith sold 98 paperbacks and 49 hardcovers. Okay, so that is just a refresher on that last standard, solving systems of equations using modeling.